Hello, everybody. Let's welcome Dr. Joseph Bob Coleman. Joe got his PhD right here at Princeton a few years ago, and now is a researcher at the University of Washington and a fellow at the Santa Fe Institute. So you might wonder, how does he split his time between Seattle and Santa Fe? Well, it's easy. He actually lives in Brooklyn.
Queenstown. Yeah.
Right. And actually comes down here to Princeton once in a while, and so that's a great thing if you're thinking about potential collaborations. Now, I'll say that I have been over and over strongly influenced by Joe's writing on social media and other topics. One of his most notable papers, he's the first author of a paper called Stewardship of Global Collective Behavior a few years ago in PNAS, and one of the things I took away from it is that when it comes to complex systems like social media, there's a deep structural mismatch between the way that science traditionally works and what policymakers need and the timescales on which those need to happen. So those kinds of insights have kind of forced me to shift how I do my research as well as my policy work. So I kept seeing Joe's name in papers over and over, and I looked him up, and I realized that his PhD was actually in fish and ecology more broadly. And I was very surprised. I assumed he had made a pivot at some point. But after meeting him and learning more about how he works and talking to him, I realized that what he actually does is applies the insights about complex systems that he developed in his doctoral research to topics closer to our interests, such as social media. And so by treating complexity not as a barrier to research, but rather the subject of research, Joe's often able to go one or two levels deeper on a topic than most of us are able to, and that's something I've really appreciated about his research. And the last thing I'll say is that, in a lot of ways, CITP research is about speaking truth to power, and I don't know if I've come across anyone whose papers are consistently about speaking uncomfortable truths and not being afraid to make enemies. And that's not just when it comes to industry influence and research, which he will talk about today, but also criticizing the work of powerful researchers, which in many ways is harder to do because these are the folks who are peer reviewing our papers and reviewing our job applications and so forth. So I've really admired that. And so with that, I'll turn it over.
Thank you. That was a fantastic introduction. You should give my PhD advisor notes. I love you. So actually, speaking of which, I'm happy back at Princeton because the last time I gave a talk at Princeton was during the pandemic. This is my PhD defense, so that's already. And so I'd not been able to give my FPO like I was planning on campus, so I'll pretend this is it. But like Arvin mentioned, I came here to study animals. This is not my work, this is Matt Lutz's work. But it's really interesting collective behavior. These are ants and they're following a really simple rule. They walk along pheromone trails, they lay down pheromone trails. When they get to a gap, they just stop for a little bit. Someone walks over them, they stay stopped. Super simple rules. Creates this bridge formation, which optimally reduces travel time for the group as a whole. But these same rules, in a slightly different context, turn out differently. So here, the ants are following the same rule. They walk along a pheromone trail, they lay down a pheromone trail. But they started going in a circle, this torus, and because it's self-reinforcing, it's a little hard to see on here. They can get stuck like this until they starve. It's actually adaptive for reasons that are way complicated to explain in this talk, but you can have these sort of same individuals, same rules, different contexts, yield very different functional behavior at scale. And so I want to bring this piece while I was here during my PhD. This is the pivot called Why Did Donald Trump Get Elected? Ask the Bees. And I took some of these ideas from collective behavior and applied them actually to algorithmic bias and decision-making online. I made this argument that if we took our honeybees deciding on a nest site and we centered their preferences and then self-reinforced it with their preferred information, you would actually never get a good decision and it could go into a very different place. And I stand by a lot of what's in this piece. I reread it today to make sure it wasn't bad before putting it in here. I think it's still okay. But that then led to this workshop we hosted here with Miguel Centeno, who I think is now the something dean of the SPIA. He's like, I have $30,000, do you want to do a workshop? And I was like, that sounds great. That workshop turned into this paper, which Arvin mentioned as well, and is sort of the normative framing, I think, for the talk today. And being an ecologist by training, the stewardship thing really appealed to me as a way of thinking about tech policy in general and evidence-based policy more broadly. And, climate change is the one that I was sort of raised around. And so you have these sort of like design and use things that turn into mechanisms that then have externalities, which exert some effect that we care about. Science studies all this and then informs policy or design directly. And then this whole cycle ideally is like evidence-based policy. And for complex systems, it needs to be dynamic and change over time. But what might not be as familiar for everyone in this room is the history of climate science and how it kind of came about. So this is one of my favorite papers. I thought it'd be good to give a tech policy talk on a 150-year-old paper to start with, by Eunice Foote in 1856. And she does this really cool experiment. She takes tubes and fills them with either air or carbon dioxide, carbonic acid gas, she calls it, puts them in the shade or sun and measures the temperature after a little while. And lo and behold, the one with CO2 in it gets warmer faster than the one with air, and also does with humidity. And she writes this: an atmosphere of that gas would give our Earth a high temperature. And if, by suppose, at some period in history, the air had mixed with a larger portion than at present, an increased temperature from its own action as well, from increased weight must have necessarily resulted. She's like, if in the past we had higher CO2, it was probably warmer. We have more in the future, it'll probably be warmer, which is completely true. This is from playing with tubes. And then in 1896, Svante Arrhenius did a global climate model. So he took and worked out the math by hand for a bunch of latitudes across the year, how much you'd have this sort of blanketing effect, and estimated the change in temperature as a function of different amounts of carbon dioxide. This is like without a calculator, the amount of work this took, for undergraduates, I can't honestly imagine. He got a Nobel Prize, but not even for this. And he's off by a factor of about 2. His predictions are like twice as high, I think, but he underestimated how fast we'd produce carbon, so we wound up kind of balancing out a little bit. So he figured out climate change about 10 years after the invention of the automobile. We had plenty of time to fix it. In the coal industry in 1966, this wasn't even controversial back then. In this piece, this recently unearthed Mining Congress Journal obscure thing, they say, like obviously, if CO2 keeps going, it's going to increase stuff, melt the polar ice caps, and probably inundate some cities. And this is the coal industry just being like, we know this is happening. There's no hedging language here, like maybe it might, like it's predicted this is probably what's going to happen. Exxon made these global climate models that are an extension of that original model. You just take and make more squares in the earth, basically, and add more data, more predictors. In this paper, these models were unearthed a bit later. They started in '77, the light gray line towards 2003. The red here is data. They did a really great job predicting future warming trends. Some of the best early models were from Exxon. Shell had a confidential report, and here they say like it's really tempting to wait because we're not going to really be able to measure this till the end of the century, this change in temperature. It's tempting to wait, but like it's going to be too bad, so we really have to actually do something about climate change. This is from Shell's internal reports. And then this graph, which I think is maybe one of the more famous graphs in science from Michael Mann's work, is the hockey stick graph. So he actually measured it. And just like Shell said, at the end of the century, they got good measurements, and it was sort of convincing. The trouble, of course, though, is this triggered a lot of climate denial, and Mann has these 6 stages he talks about. The first is, well, it's not actually going up. Carbon dioxide's kind of the same. Even if it is, there's no convincing evidence of warming. Even if there's warming, it's because of natural causes. Even if there's warming, it's the human impact, it must be small, it's from other things. And even so, the changes will be generally good. The plants will get bigger. And then maybe it's too late anyway, and we'll have to wait for some technology to save us from it, right? This is sort of a series of steps you can take when denying climate, so you give a little ground and you keep doing it. But despite this consensus formed, this is just kind of a count of papers. The blue is the ones that either like have no position or like implicitly endorse climate science, like climate change as being real, and the red are the ones that don't. So like the consensus in the literature is quite strong, but the general public too. This is a study we put out last year, measuring climate change belief, policy support, willingness to share things on social media, and this trees planted task that basically we asked them to do a really annoying series of pages, and for each page they plant a tree, and as I understand it, this is like a measure of willingness to sort of put your money where your mouth is. But across all of our measures, in every country, a majority of people believe in climate change and support policy. like a very solid, clear majority. So people are on board. And we had some policy advances. This is the Inflation Reduction Act, which is kind of fantastic climate policy, despite the name being about inflation. Predictions are that basically every measure, the IRA would reduce carbon emissions and improve our kind of path to lower emissions in the US. So about 166 years from the scientific concern that was correct to like effective policy in the US. That's the time frame that we went through. And I think, we have these wonderful models, and we had a good enough model to make the decision we had to make 140 years ago, 30 years ago. But our uncertainty really is human. This is a wonderful paper from Stefan et al. To kind of displaying time coming towards us and then the Earth here. And if we do stewardship, we can stabilize the Earth. And if we don't, this hothouse Earth, things get worse. So we're kind of at a decision point. And the uncertainty really is whether or not we address climate change, right? This is the fundamental question. So collective behavior is the real missing piece of the model that we don't know how to model yet. And it seems to be going poorly. The IRA, more or less is dying. This sort of executive order terminates the Green New Deal. Here's Sam Altman. It's not just politics. Like, it's nice to sort of say all the politicians are bad, but this is also a lot of really influential people. So he said they'll need trillions in infrastructure, and he claims that it'll happen incrementally if we keep pushing AI, but we'll fix climate. Good. Establish a space colony and discover all physics. These will become commonplace things. Need a limitless intelligence and abundant energy, the ability to generate ideas, and the ability to make it happen. We can do a lot. Here's Eric Schmidt. He says we need energy in all forms, renewable, non-renewable, whatever. And many people reject the demand for industry will go from 3% to 99% of total energy generation worldwide. We need this, right, to fix climate change. So this is a problem. And I think the important thing is renewable, non-renewable, whatever. That's just a line that I actually think about a lot. But where'd they get this from? Why is AGI such a big deal? So I don't know how many of you guys are into the Harry Potter fan fiction. I really hope none. Not because of fan fiction or Harry Potter, but because of this. This is Elliot Yudkowsky, who wrote this series of Harry Potter fan fiction in the 2010s era, talking about rationality and developed sort of a philosophy of rationality. He's an autodidact who left school in 8th grade and taught himself physics and math and computer science and AI and everything else, and wrote this series of Harry Potter fan fictions about his beliefs on rationality, but it's also a lot around artificial general intelligence, and spawned these rationalist communities that cropped up all around. If you're looking for roommates in New York, be careful, especially if you're looking for roommates in the Bay Area. But it had some adherents like Elon Musk, Peter Thiel, Vitalik Buterin, Dustin Moskovitz, Jan Tallinn. You have a much more extensive list in your head, Adam, than I do. And so some of this kind of group of rationalists sort of turned into this, if we build it, we'll die. His book came out recently. There's a review of it on The Atlantic that I recommend. And he basically says that if we build the AI God, it will kill us. Different view from Altman. Dario Amodei sort of also thinks we're going to build God, but thinks it'll be a beneficial or benevolent God. Machines of loving grace. He also has this sort of climate change will be solved thing. And like the people are taking this seriously. The New York Times writes about this all the time, says AGI is coming. The Atlantic gave Yudkowsky and Sora as a column. And Forbes is taking this seriously, mentioning the United Nations is considering this is all very important. And I could do a bunch more examples, but there's basically Silicon Valley cults are aiming to spend trillions of dollars and abandon climate goals to build God, who they hope will save us from a thing we've known how to address for decades. And if this sounds far-fetched, ask him. This is Adam Becker's book, More Everything Forever. That's Adam Becker. It's a good read. But to the point of collective behavior, I think something's just deeply wrong with it. I don't know what it is, but it's kind of weird that we're like now on year 170 of this problem, and we're like, what if we build God? Like, it's getting a little strange. And it's not a hypothetical or a fringe thing. We're moving trillions of dollars in capital, right? This is huge collective investment, the size of a World War effort kind of thing, to build God. And so I think, our collective behavior is off the rails, and it's easy to kind of make fun of and mock these people, and you should. But they got these things online on a Harry Potter fan fiction forum. That idea spread and grew through the internet, through communities that formed there in the Bay Area, where internet communities are kind of a part of life, and created a really strange mindset that now is changing the course of our future. So there's something obviously going on with the internet. But we really can't wait 166 years this time. I think that's the most important thing, and take home for hopefully all of you, if nothing else. So you have this stewardship idea, and what does it look like for the internet? So, for example, you have social media, maybe LLMs. There's some mechanisms like algorithms and bad actors or bad behavior or whatever else. These exert externalities like polarization, extremism, mental health issues, misinformation. That's what fact we care about, and then science has to measure these things and inform policy. So here's one example with polarization. This is a great piece by two of my colleagues, Phil Lorenspring and Stephen Lewandowski. And they kind of went through an exhaustive read of the literature and took a really simple measurement, which is they just kind of counted, is social media kind of in each of these sort of categories harmful or beneficial for democracy as per one study. So each unit here is one study found harmful, gray is mixed, blue here is beneficial, and they just sort of counted and tabulated stuff. But it looks a lot like the climate science thing, just with a lot fewer papers. So pretty strong consensus here that social media might be bad for democracy and cause polarization. Great, we can get to work. We now have sort of filled this in. We can say how do we design a less polarizing social media? We're ready, right? The trouble though is that if you look at sort of reviews, it's apparently not causal, right? That's the argument that's made here. This is a paper I've been working on with Arvin for a couple of years now, and we've got in review or some review yet? Yeah, it's in review. But long story short, this paper, Misunderstanding the Harms of Online Misinformation, said, well, yeah, there's a lot of associations and correlational work, and some of it's a little more causal, but the best causal evidence failed to find any effect. And by best causal evidence, they mean experiments. This is sort of synonymous here, and specifically these three are the ones they cite. There's this one study on Facebook and Instagram deactivation. They say there's no significant effects of social media across access on polarization. Another one says, for these primary outcomes, they can basically rule out any kind of strong effects on affective or issue polarization in individuals, and these sort of things as well. And then in a third paper, they said they found that reducing exposure to like-minded content had no measurable effect on political attitudes, including polarization, extremity opinions. All three of these studies published in top journals, Nature, Science, and PNAS, all experiments, no causal effects. Now, each of these rely on randomized control trials, and I don't know what the background of folks in this room is, but an RCT is basically the experiment you think of. You take control and treatment, you randomize your participants, you assign them to treatment or control, and then you assume that the randomization helps you deal with the confounds that might introduce otherwise. Then you measure some outcome difference between the control and the treatment, and that's your causal estimate. These are a workhorse of science. This is how we regulate drugs and how we do lots of things. They're great. They're just not great for this purpose. And often they rely on withdrawal RCTs. So one of the problems with studying social media is that everyone pretty much uses it. And if you wanted to expose people novelly to social media, you'd find a very unique population of people who've never used it, right? Very hard to find and not representative of everyone else. So instead of exposing people, they tend to have them either stop using it, or they change their algorithm a different way, they withdraw a feature. This is a sort of general design. This is a natural constraint that's hard to get around. But in our paper, we discuss, there's some problems with RCTs and we apply them to complex systems. So the first, and the most, to me, important thing is the global outcome isn't the sum of its parts. Our ants before had the same rules, but the context really changed the outcome, right? And this is one of my favorite examples of this. It's a paper by Stewart et al. That Carl and I wrote a little write-up of in Nature. And on this left network, there's, I think, 10 orange dots and 8 blue dots. So the orange are in the minority. And they're doing sort of a voting game, like a game theoretical voting game, and they prefer to avoid gridlock. and they're kind of weighing their neighbors to see, like, are my neighbors in support of me? Are we gonna get gridlocked? Do I have a clear majority? I'll vote accordingly. On a random network, like orange pretty much always wins because they have the majority. You can create a filter bubble network, in which case you get gridlock, even though there's a clear majority, because individuals are influenced to think they're closer to gridlock and then vote against their interests. You can take this a step further and gerrymander the structure of the network to where the blue wins routinely, even though they're in the minority, because they've convinced orange that there's going to be gridlock, and then they vote against their interests to avoid gridlock. And so the structure of the network, the same individuals, nothing has changed at all. These are actually here just theory, it's just math. You get very different outcomes, right? And so thinking like about individual effects in a randomized control trial and trying to extrapolate to the systems is hard. And so we have these sort of whole systems of social media networks. This is Twitter during the 2020 election by my colleagues at University of Washington. It has this kind of large macroscopic structure that probably almost certainly affects the decisions in the large scale dynamics that emerge. But you know, the argument with these RCTs is that the whole is sort of like sum of feeling thermometers, right? And so you can't really measure this structure with a bunch of sort of individual measures of how you feel about other groups. So you're missing a lot of the data, a lot of information. And so the second sort of problem is hysteresis. This is also called path dependence sometimes among social scientists. And this is really a problem with withdrawal studies and trying to reduce some feature of interest. So imagine, for example, instead of taking time off Facebook, we had some participants take some time off driving their cars to reduce their carbon footprint, right? And we asked them, you know, how do you feel, what's your experience of severe weather? You know, do you have it never, often, always? And then they measure it, and we compare our control and our treatment group, those who drove and those who didn't. I'd wager we have pretty minimal effects, right? But we'd be wrong to conclude that there's no causal effect of greenhouse gas on climate change, right? Those effects have already happened for the most part, and we can't just reverse them by taking a little bit of time off, especially with a few individuals out of a larger network. A third issue here is feedback loops. So this is a common feature of social systems. We were seeing it in the ants going in a circle, for example. So this is an experiment that most of you are probably familiar with. It's sort of one of the big papers in social media research, put out by some academics alongside folks at Facebook. They ran an experiment where they had like an I voted thing, if I recall correctly, and others saw the I voted thing, and then they could vote too. And they measured the direct turnout of seeing the social information about voting, which was 60,000 voters, but they also measured like further contagion, and that was another 280,000. So the direct experimental effect was only a tiny portion of the total effect right here, because this amplification process that they're not measuring, here they measured it, but you could miss measuring, is responsible for most of the effect. So it's hard to do an experiment and then actually estimate the magnitude of the thing you really care about. And the last one is sort of a funnily named thing called CITP, or spillover, also known as like the stable unit treatment value assumption. I think this is the least helpfully named thing in all of statistics, which is saying something, but basically it's that an individual's outcome is only impacted by their own treatment and not by the treatment of others. So imagine you have a chronological and an algorithmic newsfeed, and so some participants get put in chronological and the rest are in algorithmic on the website. Like on Facebook, this is the dynamic experiments. Even if you're in chronological, if none of your neighbors are, the people you follow, you're gonna see things recently posted by them that they saw algorithmically, right? And so then some of the algorithm gets kind of spilled over into your effect. You're not isolated. This is from a LinkedIn research blog talking about CITP. And on the right here, you see that there's like a little bit of the treatment effect sliding into the control, and here the term is a little bit reversed, but then you wind up underestimating the effect. And so this really actually great blog post by LinkedIn, the only time I've ever gone to LinkedIn, is they said, you know, what if we take instead randomized clusters of the network versus individuals? We randomize the chunks in the network as a whole to try to like estimate the spillover effect. And this was an experiment looking at engagement with different feed algorithms. This is very relevant to the sort of things that we saw in those studies earlier. The top two lines are the ones that matter, especially the far right column here. If you just randomize as a normal experiment, the effect size is 0.21. If you do this cluster-based randomization, it's doubles, right? So the effect size gets much larger. And this is like not even the scale of the network as a whole. There's still spillover happening. It's just a little more local. And so across all of these things, in this paper, we argue that a lot of the randomized controlled trials will tend to be biased towards finding no effect, just implicitly biased because of all these sort of issues. And in assuming they're causal, we forget these sources of bias that are required, that can arise from failing to meet assumptions of randomized controlled trials, and especially in complex systems. This paper is up on the archive. It's in review at Nature Communications. We'll see how it goes. It's been a hard road to publish for reasons we can chat about later. And so I think, but just more broadly than polarization, we don't really have consensus on any issues so far. Like mental health is a giant subject today. Polarization, as you mentioned, the impacts of misinformation, whether social media increases extremism or how it impacts education. Like we're 15 years into earnest research on it, and I don't think we have much consensus over anything other than it increases news knowledge and probability of voting on average. Like those are the two things that I think are consistent in the literature, or consistently believed in literature. So I think like a decade of failure to reach consensus suggests sort of a deeper problem that we need to address, because we are like, I've met a lot of the scientists who worked in these studies, and they're all very, very bright and very nice, and a lot of them are very invested and earnest people, and we're like not getting there, and that's I think a problem. And so my colleague Jennifer Jaquette wrote a nice companion to Naomi Oreskes' Merchants of Doubt called The Playbook that goes through sort of the strategies of how industry undermines science. So a new paper that I'm going to talk about for the rest of my time here is basically trying to map this to tech policy. So each of these three studies are collaborations with Meta about Meta, right? I think that's an important thing. Meta had delivered the data, co-designed the experiments, and chose the researchers who then chose the rest of the researchers, right? So there's sort of a network effect there. And Michael Wagner, who is the rapporteur for this, wrote this piece called Independence by Permission. And he said that one of the really challenging things here is that as academics, we can't study these sort of algorithmic changes on our own. We have to have permission and sort of work in the space that is allowed for us by industry. And then in that summary that kind of cited these things, this is by a bunch of big names, should not have had this talk recorded. They have a competing interest statement. They say there's no competing interest, but provide the following information for transparency and disclosure. I'm glad they did. Two of them worked for Microsoft, one currently works for Microsoft, one has had funding from Meta, two of them are participants in this Meta collaboration, one got funding from Google, and two worked for Yahoo, right? And these are the not competing interests, but these are like just relationships to tech that they want to disclose. And again, I'm glad they added this, but it's interesting that it's seen as no competing interests. And if you read that paper, going back to Mann's 6 Stages of Climate Denial, there's direct parallels throughout it. So they start out by saying, yeah, well, traditional news is still what most people read, and so like social media is not really changing things very much. Later on, there's an argument that there's no good evidence that things like misinformation cause harm. They even kind of make this argument along the lines of, it's not really algorithms, it's the elites that do this, that they're an important part of it, not algorithmic amplification of misinformation. Then they do the like minimizing thing where they say, well, it's the effects are probably small because it's only a tiny part of people's diets. This is like direct parallel to like CO2 is only a small part of the atmosphere and methane and sort of thing. Then later on they say, actually in Bosnia and Herzegovina in one study, it made things better, like, right? So there's like, the benefits could be good sometimes too, and we'll get to that. And they say, well, actually I think Facebook and YouTube might have already solved this, right? And then like, not exactly. They say it might have been worse, and that's probably a little better. And if you look elsewhere, people will say, oh, LLMs will come in and fix misinformation online. Which this is a great audience for that, because I don't think you believe it. But I mean, this is not to shade the authors. I think this is just a a natural position that to occupy sort of a contrarian viewpoint sometimes, and it really leads to this. What's fascinating is we have all 6 of these in one paper. I don't think that even happened in climate science. But I think it really reflects a deeper issue, again, not to put the individual scientist here forward, but the structure of the field. I'm a collective behavior scientist, I'm not interested in individuals. Tech companies' capacity for producing doubt here is kind of if BP owned all the thermometers and had more money and staff scientists, right? So the space that we're operating in is much, much worse. And so this new paper that I'm very excited about, it's in review at PNAS right now. It's sort of the spiritual successor to the last one. Much spicier, argues about the kind of the risks of industry influence in tech research that are unavoidable at the moment because there's few paths otherwise. So I'm going to round out by talking about what these are. So the first is selectively publishing internal research. This is a mechanism that they can use to influence the way we think about their products and platforms. So if you look at every paper that Meta researchers have published, I haven't found one that is negative or bad. If anyone knows of a paper made by Meta that identifies harms that they've done, please send it along because this is a claim we make. So they say that it improves political participation, helps with unemployment, it increases social capital, keeps families close, helps with grief, promotes exposure to diverse ideas, and even staves off death. I don't think they've said it does your taxes yet, but I'll check. Wow. Meanwhile, this is from September of last month. I don't know if you saw this, but there's a couple whistleblowers, as there often are at Meta, who said they buried child safety research. In a testimony to Congress, apologies for not giving a little more warning here, they said that when they were doing their research on the platform, they routinely noticed that on Meta VR in Germany, children were subject to demands for sex acts, nude photos, other things that children should not be exposed to. Meta demanded that they erase the evidence of this dangers, right? So they do all these good things, but then they're willing to delete this evidence and actually argue that their researchers shouldn't study it because it's potentially harmful. And it wasn't a rare occurrence. They said it was very high, and they estimated that basically any child in a VR space would be experienced this at some point in time, right? So this is the sort of space we're seeing publications about the things that they're about saving you from dying, and then where this is getting buried. And that changes our perception of the total costs and benefits. How many studies have they ran internally, and how many have they published? It's an interesting thing to think about. They probably know more about social media's impacts in the world than the whole of academia does, and it's all buried behind trade secrecy. That's bad. But also, there's a second kind of model here is selective causal focus. They can take and redirect us, say, from the algorithm to user choices. And you see this in a lot of the research. They say, well, it wasn't algorithms, it's really humans are seeking misinformation. We really like to be misinformed. We enjoy it, but yeah. Yeah. And so, here's an example of how they can sort of, even while seeming like they're helping out, wind up biasing how we study things. So on January 29th of this year, this Center for Open Science slapped up this real quick press release, or it felt like that. It was a little bit loose in the details, saying we're going to work with Meta to study well-being topics. It's kind of vague, share data to study well-being topics, right? And the reason I think that Meta was into this is because 2 days later they were dragged into Congress to apologize to families for all the bad things their products are doing. And during that, they said, you know what? We're really trying. We just signed up to work with Center for Open Science to try to figure this out and look at well-being and help people thrive, right? So this is about $1 million to get, turns out, collaboration like this. And they're funding 4 research projects. I think one's happening here. I would love to chat with whoever's doing it. I'm all ears. But, and these researchers, I don't not blame any of them. This is the only way to get this kind of data, is to go through this process. They only allow 4 groups, 4 projects. What's interesting though, is you can request data about Instagram and platform use, but you can't get any information about content people generated or saw. So you just get really coarse information about their time spent on platform, number of clicks, but not what they're clicking on. This is what you're allowed to study in this project. And internally, this is some work by Jeff Horowitz that came out earlier last month now, late last month. They were doing work on the kind of content and how content can cause harms. And so here, they took and looked at teens who have body dissatisfaction and compared them to other teens, and they found that teens with body dissatisfaction have about 10% of their feed composed of eating disorder adjacent content, as opposed to 3% for everyone else. And then more broadly, 25% of their feed is kind of negative, harmful content in general, as opposed to 13% more broadly. So people who are struggling get much, much more dreary feeds on Instagram. So they know, and they express worry that the content being delivered to teens is causing mental health issues. And then when they deliver the data, they're not delivering content data to scientists. This is a goose chase. And they'll get null findings, and then they'll point to them as evidence they tried and didn't find anything. And so, another mechanism here that's somewhat related is design bias. I want to give one example that I think is telling, and I want to bring back Bosnia and Herzegovina again. So in this study, they did this withdrawal experiment, take some time off the platform, see how you feel a little bit later about the opposing ethnic group. And they found that, they argued that taking time off actually reduced willingness to cooperate, which means that being on it probably would increase it. This is the argument of withdrawal studies. And it's significant. P is less than 0.1, right? Same senior author, Josh Tucker, on this, and one of the experiments on also a deactivation study published in the same journal, right? This one is looking at the effect on voting outcomes in the US presidential election in 2020, and they found, they say 0.2 or 0.026 units, which is units here is like proportional to percent votes. It's a 2.6% swing in the vote away from Trump and towards Biden for taking a few weeks off of Facebook, which is a huge change in the vote. 2.6% is like what elections hang on, right? Not significant, but equals 0.015 because they applied this correction for multiple comparisons, which makes for a much more conservative test. And so there's about considerably more evidence that the election was changed than there is that it helped, Bosnia and Herzegovina get a little better off when they took some time off of Facebook, right? In fact, this is an order of magnitude, almost, less likely under the null, this finding. And it's a good indicator that this study was underpowered. You can't detect a 2.3%, 2.6% change in vote share. You might have needed more people. And then also the preference for RCTs, right? So they really like to fund and conduct these randomized control trials that have a lot of reasons why they bias towards zero. And if LinkedIn's figured out that randomized control trials can be biased towards the null, you think Meta might have. So the final thing here is selective funding for access and funding for researchers. Also Kaylin O'Connor made all these figures. She's the best. And I highly recommend collaborating with her for lots of reasons, among which is she makes great figures. That's like sort of the least of all the reasons, but it's a great one. So this is really one of my favorite papers. It's by Manuela Fernandez Pinto, who's at the University of Los Andes in Bogota. It's just a really great paper. And so she and Daniel look at this question of what happens if you have a bunch of earnest researchers who just have some epistemic diversity. So some of them kind of use some methods, say, and some use others. Some have some kind of prior beliefs and some have others. And you have industry like selectively fund along that line of diversity. So that everyone here is an earnest researcher. You're just like choosing the ones that kind of fit your goals. So for example, you have researchers who want to study algorithmic impacts on misinformation, ones that want to like use nudges to reduce misinformation exposure, and you just like fund the ones with the nudges because it kind of puts the blame on people, right? And with funding, the industry agent, of course, goes to the wrong answer here, which is like 0. Combining industry and a random agent actually also goes to 0 because that bias pushes the decision-making towards the industry for an outcome, and then the random agent actually does find by itself. And so even if you have earnest scientists who are honest, selective funding and access, at least theoretically, can entirely change the conversations we have, what we study, and the conclusions we come to. This is a collective behavioral effect. Again, collectives, not individuals. And they say that this is what they're doing. I just saw this today, and I was like, that's exactly right. Collaborative research aligned with our mission, right? And so like, they've given out a bunch of grants, Meta has over the years, and fellowships, and as long as you're aligned with their mission. And if you're not, you get legal threats. The Facebook Ad Observatory at NYU got some like shut down more or less by Meta for a while because they were looking at the kind of ads that Meta serves, which was not aligned with their interests or their mission. And so, and the question is like, of course, there's these influences, but how much can we tell? Like, how can we know if research has been influenced? I have a lot of data coming down the pipe on this, but not yet. So, invite me back sometime, if you want. But there's been more than 700 grants and fellowships awarded publicly, like just actual grants, and many of these to multiple researchers. But about half as many papers currently list Meta as a funder on OpenAlex, right? So most of the grants either produced no paper, half, or they just forgot to list it. And if we look at competing interest declarations, like this is that one example, but this doesn't suggest, this isn't like maleficence, right? Like this is very transparent. It's just something about the norms here is very strange. And here's another example that I really can't explain, but I think speaks to the variation in norms. These are the same authors in the same data set, published in the exact same year. And on the left, they declare competing interests, and on the right, they declare none, which I think is interesting. There must be something about the way the questions are thought of that relate to, I honestly don't know. But both these involved an experiment in which people followed a news source on Instagram and WhatsApp and changed their exposure to the platform. And even stranger still, a subset of these authors had to issue a correction last year because they forgot to acknowledge competing interest declarations, right? So there's some very strange things happening with norms here that I think are a larger problem. And I don't quite know where that arises from. And so the other kind of thing we talk about in this paper is this open science, which is a big discussion as like a possible mechanism to help keep these collaborations honest and open. And this is from the research blog that Meta put out. They said we did a pre-registration of the studies, which meant that people can check what we did and that we didn't hide any of our results, right? And a pre-registration, for those of you who don't spend too much time near psychologists, is basically putting up a research plan before you go to do the research, like saying what tests you're gonna run, how you're gonna structure your experiment. Then you follow it, and the idea is then you couldn't do QRPs or p-hack or whatever else to coerce your results. The trouble, though, of course, with pre-registration more broadly is that people tend to deviate from that plan quite a bit, and often without saying they did, or without a sufficiently detailed plan to know that they did. So in this study by Klassen et al., only 2 out of 27 studies that were pre-registered contained no deviations from the plan. Quite common, which means that they don't really do much. And here are the deviations from one of those studies with meta collaboration. If you go down page 212 of the SI, you can find 7 pages of deviations, right, disclosed. And you can't actually check their results because you're not able to regenerate their raw data to their fixed data to see what would happen if they'd done it differently, right? And some of these are pretty substantial deviations, like changing criteria for significance kind of things, or dropping measures. But they also forgot to disclose this deviation. During the election, they initiated these break glass policies. There's like 32 different changes to their algorithms and platform design that were intended to reduce exposure to certain kinds of content online, and it did. So while they're trying to study their platform impacts of things like their algorithm, they changed the algorithm in the direction that would minimize the effects and didn't really account for it and didn't really disclose it during the peer review process. In this paper by Bagchi et al. Kind of pushed back on that. Then in reply, the author said, well, our data's better, more or less. I mean, it was not exactly that, but it became quite hard to push back, even when you discover a deviation like this. I don't even know if the authors of the academic authors were aware during the time, but even if you find a big change, then it's really hard. You can't reverse engineer it. So these sort of open science norms don't allow us to actually inspect their work and reconstruct things and see what they hid, because we don't have raw data access. So I think that's my time. This paper's up. You can send them around as well. And I gave this talk actually in Germany. I don't know if you guys know Aline Coleman in psychology. I gave a version of this talk in Berlin, and he goes, "This is really extraordinarily depressing, Joe. Do you have anything hopeful to add?" So I added a hopeful slide. I think we're in the industry influence phase of stewardship. That means we've done in a decade what to climate science a century, right? It's great. And so the next step, I tried. The next step is sort of wresting control from industry, right? So we know what might be wrong. We kind of have an idea how to solve it. You just have to kind of regain our independence. These are like some of the wonderful folks that have supported my career and my affiliations and my whatnot. And thanks, that's all I got.
Thank you for this awesome talk. I want to ask about sort of how do we get to the point of wresting influence from industry. And I mean, in particular, I'm thinking a lot about conflicts of interest that arise in research where you get funding from industry. And like, I'm in a very, I think, fortunate position to have never taken direct industry funding for my research on social media. But part of the reason that I've been able to draw that line is because I'm at a very well-resourced institution. I've been at well-resourced institutions, and that's a rare and privileged position to be in. So like, what do you say to researchers who are like, well, I want to study this, I have expertise to study this, but like the only way I could get my research funded or supported is to take industry money, like especially given that science funding in the US is being cut left and right. Like, you know, I'm often in conversations like this, and I'm just curious what you think about.
Yeah, so I think first and foremost, like, again, there's no normative judgments on taking money from companies or data access or otherwise. Like, obviously, we don't have a lot of other options, like things like theory or surveys on Prolific. Those are like the three things you can do. Or you can scrape data or run browser plugins, and all of these things can run you into legal trouble, which again, if you're not a well-resourced university, is quite awful. Being sued isn't fun, it's just not a fun experience. But to the point of like, that's the first part of the question. Second part of the question is they mostly fund people at well-resourced universities and collaborate with them. So I don't think it's necessarily like there's a lot of people like at R2s begging for money from Facebook and then getting it. And what they do get is often like not a lot. These grants are quite small initially. The third part kind of digs into some of the data stuff that I want to talk about eventually, but a lot of the funding, a lot of people get one Facebook grant for $50,000, and some people get a lot. And so I think the problem really isn't that person who got $50,000 5 years ago for like this one thing Facebook did, but someone who's had like repeated collaborations and lots of time spent. And not that that person's a problem, but that their position in the field that they might occupy because of those advantages might bias the sort of perspective of the field. Because I think just like we have the norms already, we have competing interest disclosures, those are a thing that exist. Journal policies should forbid research, like peer reviewers and editors from handling a paper if they have these conflicts. Reviewers should be able to be made aware of it so they can kind of judge accordingly. So I think we already have the infrastructure, we just have to actually apply it. Yeah.
Thanks.
Yeah.
So I love the work you're doing here. I want to add three things
Me
that
too.
I think are not considered in the way that you're thinking about this statistically.
Hmm?
So one is the way in which the fields that study this stuff were built up around money from those companies, and having participated at CHI throughout the 2000s
Yeah.
and watching that happen and sitting on panels with people that were conducting the research, they were of course all funded by these companies. But it goes beyond just where the funding comes from. It kind of produced a sort of normal science in which it was like, okay, like in the Kuhnian sense, in which it was okay to be like, okay, you found that under that circumstance, but what about this one? And then that became the opportunity for the next grant, right? I remember sitting on a panel with like Sharina Schonenbeck talking about like how important it was for women who had babies to like find each other on the internet. And I was like, but you're putting pictures of your naked children on Mark Zuckerberg's photo album without them consenting. Well, you know, we'd have to figure out if that, like that's a thing we'd have to investigate later, right?
Yeah.
And that becomes, so kind of like it kicks the can down the line, but it also like creates an entire paradigm for normal science in which one then just finds like what's the next little problem?
Yeah.
And the next little problems are always kind of one-offs or the trickle down thing. So that's one issue. The other is that we inadequately, in general, in this field, I find, have poorly accounted for the role of technology, broadly speaking, in any of these kinds of systems. I completely agree with you on the ants. I think it's a great way to think about collective behavior. Coming out of sociology, we have lots of ways of understanding why networks matter and why like the individual focus isn't great. But also, like as a scholar from science and technology studies, we have really sophisticated ideas about how different technologies are part of the mix of the ways in which sociality happens. And that not only when you inject a technical system, but the entire apparatus behind it, you force change. And there's a couple of elements to that. One is that Facebook is not the same as it was when it started. It looks the same on the surface, and everything that's happened behind the scenes has changed.
Yeah.
The algorithms are changing constantly, they're A/B testing on us at like massive scale, the move fast and break things, like they just break us in order to make money, right? Like, but that's happening too. So on the one hand, we've inadequately explained how algorithmic effects, it's not just an effect, it doesn't impact society. The algorithms themselves become the material of sociality. They are embedded in social relations.
Yeah.
And I think about like Stuart Geiger's great work on like bots and Wikipedia back in the day that were like, how do you understand Wikipedia as a system? It is a socio-technical system in which bots are active.
Mhm.
And it's not that those things are agential by themselves, but none of us are agential, including the bots, without each other.
Mhm.
So there's an entire model there for understanding that. And then there's the infrastructural view, which is basically the depth over time of like, what you say is Facebook is not the same Facebook. So we have inadequately accounted for those three things. And so I would wanna just throw that at you and be like, let's keep talking.
Yeah.
I'd love to know how those would fit into the conversation. It's not as simple as, it might be as simple as like back in the day, like you needed a cigarette in order to like socialize with people. And we kind of have to change
Yeah.
what that looked like. But the ways in which these technical scripts now
Yeah.
have infiltrated social life is a thing that we still like to gloss with an idea that technology just impacts
Yeah.
from out of the blue, as opposed to the fact that that we create things that participate.
Yeah, no, absolutely. So the first part about normal technology, like the normal science, the iterative thing, I think that really, we talked about that a little bit. I think maybe in this piece paper can't remember stayed around, but the example that comes to mind is like the nudges to reduce misinformation, like it started off.
Yeah.
Exactly. And there's always an iterative problem to fix and make it a little bit better.
Well, and also, just
yeah.
on that, like, I remember the conversations at Kai about persuasive design.
Yeah, and we should.
And it was all like, is this ethical? We shouldn't do it. And they were like building, like, I remember dating people who were like building little apps that like, the little polar bear gets happy when you bike to work, but when you drive, the ice floes on gets smaller and you get sad. And so it was like persuasive, like nudging for these. But it's good we're doing it for ethical reasons. Sorry if I'm getting very animated. I'm so angry.
No, we should chat. I think this is a good,
I'm so angry.
good.
20 years of these people.
It's much better than
But
people
anyway.
having nothing, just
But I'm
staring.
not angry at you. I'm just.
I'm around the rest of the day. I think I have a chunk of
Great.
time towards the end that's still open, the signups, so. Yes.
I was just curious, so you highlighted all these issues with RCTs, right?
Mhm.
So as an academic, as someone who's interested in studying the impacts of these systems
Yeah.
on people, like if not RCTs, like what do you recommend we do?
Oh yeah,
Or
that's,
like how do you rethink RCTs?
yeah, so there's a lot of options here. And the answer is all of it, is kind of what we propose in the paper. So, the way that climate science worked wasn't by running experiments. We didn't have two worlds, like maybe one hot, one not hot, and then like ask what happened. That early experiment, actually by foot, was an RCT in a sense. But there are a lot of other options, like you can use empirical models and then empirical data fitting theory to empirics. There's these sort of difference type causal approaches that aren't always great, but they have their limitations, but they also have their advantages. There's a lot of kind of Judea-Pearl-esque causal modeling that can be done as well. Basically, there's a whole slew of approaches, and I think what we should look for is when our theory and our varying causal approaches all sort of point the same direction, right? Because each of those, especially observational causal models, have a different failure point, which I think is something we often forget about. So like, if you look at the discourse on the observational research, each one gets sort of attacked on a certain problem, but each one has a different failure point. So they all have to all be failing at their specific failure point in order for that bias to emerge when they're consistent, right? But RCTs all have the same failure point. And so I think if they all find the same null and they disagree, it sort of tells us a different thing. And I think in the full paper, we talk about some uses of RCTs still in this space. They definitely have their value. But I think we have to just kind of do all of it and look for like consistency and coherence across things.
Super interesting talk. You mentioned this parallel between like climate science and like social media research. And so one artifact of climate science is that there were like hidden studies that have then later been revealed.
Yeah.
And with social media research, there's this like great plot that you show where like there's the red portion under the curve on the right hand side of like the hidden science that we don't know about. And I'm wondering if you've thought about those parallels to estimate what some of those hidden studies are, and if you have an estimation of what we don't know yet publicly that is known internally, what could we learn from that?
Yeah. So I don't know, does anyone here know anyone who works for Facebook as a behavioral researcher? Yeah, a few of us do. I've got some friends that do. 3 members of my lab actually. 2 members of my lab and one colleague wound up working for Meta in behavioral research. They're all quite smart and talented people, and they've been working there for 10 years now, 6 years now. So I assume they've published something internally, right? The number of behavioral scientists at Meta is huge. And it's possible they're being paid to do nothing, which some of them certainly are. But it's gotta be much larger, right? The number of papers is tiny. Like I don't know if it's a good way to estimate it though. the whistleblowers come out, there might be a way to get at that there's a really cool paper on how long a conspiracy could be held a conspiracy before someone blows the whistle, right? So like a conspiracy like the moon landing, how it would fail very fast, because the number of people involved in the conspiracy would be so large that you'd eventually get it just collapsing. But like a small conspiracy, like a local police force, can like persist for decades. So there might be a way to get at that. Looking at the rate of whistleblowers, we should chat. This is interesting. That might be actually be cool. Yeah.
I also want to ask about this parallel of climate change research to misinformation.
Huh?
There's a personal and an impersonal way for me to ask this. That reflects on me, not on you. So I'll.
Oh, either way, it's fine. Yeah.
But I was raised by.
It is being live streamed and recorded if that matters.
Okay, that's fine. I was raised by a climate scientist,
Okay.
and in the early 2000s was starting her research at this point. And one of her primary contributions is this thing called the global carbon budget, where she measures every year, the emissions in the atmosphere. She actually the other day told me on our weekly Zoom calls, I actually think you're in the stage that I was at the beginning of my career when it comes to misinformation.
Yeah.
Of having to prove out these things. But one thing that I have not been able to wrap my head around is what is the equivalent of our CO2 in the atmosphere measurements?
Yes.
And how do we convince people that this is what we should be following when this is not even something we fully agreed on in the field yet?
Yeah. So the thing I didn't talk about was it's been the last year working at the UN and the Human Development Reports Office, or the Crisis Bureau, and on their Human Development Report this year was about AI and its impact on human development. And one of the things we talked about a lot is how do we measure AI's impact on human development, right? Don't have an answer. But I think metrics are really important, and this is some stuff Arvin's talked about as well. Once you have a metric, you can start getting gamification. And the HDI itself is an example of this. It was designed to be a stupid measure not a stupid measure, but an imperfect measure that got countries fighting over who had better HDI. And it's a combination of education, longevity, and individual wealth. And now you have every year India's ours is higher than Pakistan. And they're really excited about it, even though it has been for a long time. But the countries sort of vie for HDI, and they wind up improving things inadvertently. If we could find that, that would be fantastic. I think if we had funding for it, we'd have researchers that worked on that. I think we'd find it. Yeah, very cool. Sure.
In both examples, I think that one thing that was out of the talk is kind of how were the solutions proposed by researchers or by the community a part of the reason why it was hard to push change, And to which extent do you think these things are comparable when it comes to climate science and misinformation, right? Because part of my personal concern around the interventions around social media is that I'm not so sure that there are interventions that are possible that make sense, I think that if we just if Facebook was over or Instagram was over and everyone had WhatsApp groups with people they know and a big Telegram chat, I think things would be just as bad, for example. I don't think there would be a major difference in how good or bad the world was. So to which extent do you think that it's harder or easier? How do you think about in terms of how do we propose something different in that case? Which in climate science for me seems more clear, the solutions seem maybe harder at some point in time, but they seem to exist, we should use clean energy.
Yeah. Actually, so it's funny you mentioned this. The WhatsApp is a perfect example. With WhatsApp, there was a forwarding limit imposed a few years ago that Meta developed. They went from I think it was an infinite number or a massive number of forwards to 7 or 8. Now, one of the fun things about network science is the 7 degrees of separation, the Kevin Bacon thing. So it was you could send it once, forward it 5 times, and send it 1 more time. So that's 7 degrees. Basically, their intervention made it to where you could still send it across to anyone in the network, your forwarding pattern, right? And then the group size of that went from I think it was 512 down to 256 or something. They slightly changed the group size. Alex will walk this back. There's a group from Brazil. I cannot remember the name of the authors right now. Yes. Okay. I figured you might know. Fantastic. Started looking at what if they made it different? And so in that case, for WhatsApp, changing forwarding limits strict enough, or making it even frictive, so not saying you can only forward it 3 times, but making it a hard button to find to forward something, probably could fix a lot of misinformation in WhatsApp. I think the design of that platform isn't as intrinsically broken as Twitter or X or Facebook. When those platforms, like you have such large influencers that whatever they wanna share is what everyone sees. And like by the time they get to this sort of state, they're terminal. And then like when we have these sort of researchers propose things like putting a nudge up, like having a community note on Elon Musk's message isn't gonna change viewership of it, not really, right? And so I think the proposed solutions can get in the way of like sort of assessing what is and isn't fixable, and if not fixable, what we could do instead.
I think we're at 1:15 unfortunately, but Joe is here for the rest of the day.
Yeah.
So let's thank him again.